Good morning, everyone. This is Jackson Bigley. I'm going to be your presenter this morning, and we talk a little bit about high accuracy GNSS with some of the newer Trimble mapping and GIS products. I want to thank everyone for joining, taking some time out of their busy morning to hopefully learn a little bit more about this. And if you have any questions, we certainly can take a look at questions at the end of the webinar. We try to keep it fairly concise, 30 minutes or less, just to see what kind of interest you have and what kind of questions you have and that kind of thing. The webinars can be a little challenging because we can't interact as much as in as if we were all in the same room. But if you want to enter a question, there's the area there that you can enter questions, and we'll take a look at those at the end, or I can always address questions offline. So again, thanks for joining. Hope everyone's having a good morning. We'll go ahead and get started here. And everybody on the line, other than myself, is on mute, just to keep the line a little quieter and make it easier for everyone to hear. All right, well, let's go ahead and get started here. So the way that I've got this set up is to have a few PowerPoints, kind of go through a few things, and then I do want to show you live, kind of more in a demonstration format, a couple different things as well as we get towards the end of this. So looking at our company, if you're not familiar with electronic data solutions, I assume many of you on the phone are existing customers and know about our company. Again, my name is Jackson Bigley. I live up in Montana, in Missoula, and we have our various sales folks around the north, mainly in the Northwest. We do have Sean Mitten in California. I assume most of you are probably from the Northwest area or into California, possibly Colorado, etc. But that's where we do most of our work. We've been in business a long time, and we specialize in field data collection, equipment. We do more service work now than we used to, training, support, etc. Folks that have been in this industry for a while probably recognize many of these different industry leaders. Trimble Navigation, Esri, we're an Esri Gold partner, so there's a lot of development work that we do with Esri, and we do a lot with our GIS online. Juniper Systems, they produce rugged data loggers, laser technology for laser rangefinders. Mobile Demand is a line of mobile tablets that are rugged mobile tablets. And then we have in situ and Teledyne ISCO on the water resource side. Okay, moving right along into what the topic for today is talking about, what is high accuracy GNSS, how can we obtain high accuracy GNSS, and why do we necessarily care about it, or why do we need to do that? So, and many of you have probably thought of this before, but what does high accuracy mean to you, and what exactly is high accuracy? It's not necessarily, when we're mapping a GIS people, it's not necessarily survey. So we're not always surveying a property corner or something where it's millimeters of accuracy. But in mapping and GIS, we do deal with high accuracy. We do have applications where very high accuracy is needed, and even some applications where we're trying to get good vertical data. So for a lot of folks, sub-meter data is considered high accuracy. For a lot of folks, maybe in the natural resource area, environmental scientists, wetland delineation, monitoring sites, fisheries, things like that. We start to get into a little higher accuracy requirements, maybe sub-foot or even down to the centimeter level, when we start looking at geologists that might be doing oil and gas exploration, utility workers that are going out and locating buried utilities, or we could have a construction company going and staking out a construction site, or doing a stakeout for a utility for utility poles, something like that, where the accuracy is sub-foot, I would say, or better down to the centimeter. And then you've got the applications where the vertical component is really important. So in those cases, my experience has been is typically the vertical component is related to maybe a buried utility, or probably more commonly something with the gravity feed, like the water flow. is where they're a stormwater or some entity like that interested in the flow of water and maybe feeding field data collected information into a model, that kind of thing. So you can use high accuracy for a lot of different uses. A common one certainly is underground or buried assets. If you can map those assets while they're going into the ground, certainly at a high accuracy, you're then more able to relocate them at a high accuracy. There's folks that are always trying to relocate things that are hard to find. One that I think of most common would probably be like a curb stop valve for a house on a water system that get covered over, landscapes, paved, whatever. Hard to find, but they need to find them quickly in a lot of cases and get that valve turned off. So that's a situation where you're actually going out and relocating something. Staking topography is another one where you can go out and build your own surface topography with using high accuracy. Ground control for imagery. A lot of different uses in the high accuracy realm. Okay, so in order to get high accuracy GNSS, we have to have some type of correction. So just your autonomous GPS GNSS with no correction at all is going to yield somewhere in the, say, like 2 to 5 meter range. Kind of depends on the receiver. But if you're trying to go beyond that, you have to have a correction. And most of what I'm talking about here is a real-time correction. So SFAST, I think we're mostly familiar with. That's WASP in our area for North America. That's a free satellite service that's in the sub-meter range. Now, Trimble RTX, that might be something you're not familiar with, and that is Trimble satellite correction. It's a subscription, and you pay for that service. It's similar to what many of you might remember OmniStar, and OmniStar is still available. I now think of it as Trimble RTX since Trimble owns OmniStar. So we'll talk a little bit more about that one. Some places have a VRS network, and if you have access to the internet, you can dial in and get a very high accuracy correction through a VRS network. Where I live in Montana, we don't have that luxury. A lot of places don't. Some states, like the state of Washington, has a statewide network, or Oregon, different places. But a lot of places don't have that available. A single base is essentially where you have access to a base station. Either you're getting the correction through the internet, or it could be through radio. This could be a base station you set up yourself. This could be one that's set up at a Department of Transportation or a city county building, etc., and it's made available to you. You can dial in and get that correction. But for the most part, for the products we're talking about today from Trimble, these are your correction sources that apply for real-time mapping. So the Trimble RTX correction, again, the idea here is that as we're starting to see a transition, I think, towards workflows that use apps, we might say. So some folks are using Apple devices, Android devices. They're using the cloud a lot more. And you're talking about ArcGIS Online and Collector, where Trimble has its cloud version called TerraFlex. And the workflows have changed where you're collecting data, and that data is going directly into the cloud, and oftentimes then going directly into GIS. So the ability to have real-time corrected data reduces the need to post-process data, and it makes these workflows with apps and these various devices like a smartphone or a tablet, they work a lot better. So RTX subscription, RTX correction is a nice way to get very high accuracy in a real-time environment on a global basis. So you have center point, you can get as good as 4 centimeter in real time, and they actually have a spec on this one, which is 9 centimeter vertically. So very accurate both horizontally and vertically. And then range point, one I want to show you today, and viewpoint is their other service. So you have your target applications which require real-time accuracy. Maybe these ones we're talking about where you're staking or you're going back out and relocating something. There's a lot of uses for it. It's also nice in just the fact that it's a workflow, as I mentioned, and having real-time corrected data doesn't necessarily mean you have to be in the field using that high accuracy data, but it opens up the door for that workflow using a cloud-based system and taking the data straight to GIS and saving some steps on the back end. So what type of hardware goes with these type of correction sources to get the high accuracy? Today we're talking about Trimble hardware. The Trimble R2 receiver is a brand new receiver. The G07X has been out for a while. You may be familiar with that one. That's the G07X handheld. There's the NetR9 reference station, which can be a fixed base station, or it can be used as a temporary base station on the project site. So that's called the NetR9. And then we have the small version called the R1 receiver, which is a nice small sub-meter device. So this new Trimble R2, I just had a little bit of time to start using it. I just got one of these and I've been playing around with it a little bit, seeing what it will do, and connecting up to some of these other, these real-time sources and that kind of thing. And so far, so definitely so good with this device. Now it's, it's geared all the way from sub-meter to centimeter. So you can do the 1 centimeter level mapping with this. It's essentially at that point, crossing into the survey realm. So very high accuracy capability with it. It's a Bluetooth device, so it opens the door to basically the trend in today's industry that I see is people wanting to use tablets, mainly, for the larger screen and the different reasons. There's lots of reasons why tablets are very advantageous. And so you connect with a Bluetooth device like the R2 to get high accuracy. So it brings that capability to a tablet. And it brings the multiple tracking of all the constellations. Essentially, it's very productive and accurate. So you're getting high productivity with a lot of satellites to track. You're getting the best available accuracy in difficult environments. So that's the Trimble R2. There's a lot of different flavors of the R2. You can see here, and there's a bunch of information here, but what I thought was somewhat important is that there's a centimeter, a sub-foot, and a sub-meter version of this product. And you can see the horizontal accuracies range somewhere between centimeter to 10 centimeter to 50 centimeter. So it can be very accurate. You can even get, there's an option to get a built-in 450 megahertz radio into this R2. So you can actually use it to communicate with an existing survey base station that was using radio to communicate a correction signal. So you could equip it as part of a kind of existing survey equipment. Most of your GIS folks probably aren't going to be using that workflow as much, but it is available and an option. Okay, moving on to another product from Trimble that will give you the capability of high accuracy is the G07X. So this is a little different look. This is an all-in-one device. So essentially you've got the Windows mobile operating system. You've got a field PC with the GNSS receiver and antenna all combined into one. It can range anywhere from sub-meter to centimeter. The capability to integrate a laser rangefinder has been a nice feature of the 7X. So that gives you the ability to not have to carry a separate rangefinder if you need that capability. And being as it's just connected to the device, you very quickly can activate the laser rangefinder, collect a remote position, and have that functionality built into one device. So, this device is highly accurate. It can be used high accuracy in the hand, or you can use it with an external antenna, which is a common way to go. If you're using, say, the centimeter version of this, you're using the external Zephyr Model 2 antenna and a range pole, and getting very high accuracy, horizontal and vertical. The Trimble R1 just barely sneaks its way into the high accuracy realm. It's considered a sub-meter, a sub-meter device, and it is a sub-meter device. It's, I think, best used with the free SBAS correction in a sub-meter setting in a real-time workflow. It's designed for those people wanting to use you know, an iPad or a phone with an app like Esri Collector, where your average tablet and smartphone have very, for the most part, pretty poor accuracy in terms of positioning. You do a simple Bluetooth paired device like this, and you can go from, you know, poor positioning to sub-meter accuracy in real time. And it's very small, lightweight, and easy to put in a pocket and use out in the field. So the Trimble R1 really is kind of a product that is coming. Trimble brought this to the market because of the trend of people wanting to use tablets and phones and all the apps that are available today for mapping, but that you need something with some decent accuracy for most GIS data collection. So that's where the Trimble R1 comes in. Okay, I was going to show you what it looks like, a couple different things here on what these correction sources kind of look like. So let me jump out of here, and let's first take a look. We'll look at TerraFlex here in a second. But if you're looking first off at, let's take a look at so this is for those of you who work in really rugged conditions, this is the new Nomad. Well, the screen picture probably isn't, but I'm running on my desk in the new Nomad 1050, which has its own GPS built in. But if I wanted to run, say, TerraSync and then Bluetooth connect to the R2, I would have that ability. And that R2 I could put on a pole. I could put that R2 on a backpack, kind of like going back 20 years in a way, where you're back to having a receiver on a backpack. But it is a very good way to transport the antenna when you're in these higher accuracy type environments. You need that type of, getting the antenna up and raised above the body. So a backpack is still a common way to do that. So what I wanted to show you here, so this is the Trimble TerraSync software. Maybe you're familiar with that. Runs on Windows mobile devices like this Nomad. And what I'm going to do is Bluetooth connect to the R2. And a couple things I want to show you is, so here's the sky plot as I'm connected to the R2. Okay, I'm tracking 16 satellites. So I've got both. I can show here that this is an RTX correction. So I'm using the range point RTX, which is the 30 centimeter version. I'm not using, my R2 is not capable of the center point, which is the 4 centimeter. You actually need the centimeter version of the R2 to do that. So I have the subsplit version of the R2 connected to the range point, 30 centimeter version of the RTX. I'm using 6 GPS satellites and 8 GLONASS satellites for my position. And I'm getting, let's see, 14 inches of horizontal accuracy and around 30 vertical, okay, in a real-time workflow. And the thing I've noticed so far about the RTX is it seems to really hold the lock well. I haven't had a problem with it dropping it. Again, I haven't used it a lot yet in a lot of different environments, like a forested environment. I'm not sure yet how that will interact. Right now I just have it kind of sitting out in a semi-open area. Now if I open up a data file in TerraSync and set up the antenna, the height of the R2 receiver, and then take a look at, there is a difference typically in, like in this case it's telling me if I was actually going to post-process this data with traditional methods like Pathfinder Office. Last time I looked at this, it was actually, in this case it's giving me a similar accuracy, but in a lot of cases, there it goes. It's going to actually, post-processing with a nearby base station is actually going to yield a little bit better results, as you can see there on the screen, compared to the real-time accuracy of the RTX. But on the way to look at it, I think, is that the RTX has already corrected the data. Maybe I want to automatically upload that into my GIS through the cloud. I don't need to do the post-processing. But if you're trying to do something vertically, in this case, you can see as my vertical component with real time is not maybe quite good enough to do, say, a topo map that you want to do. But if I was to post-process the data, I'm down to 7 inches of vertical component, which is pretty darn good for a lot of applications. And again, these figures are based on the receiver sitting, in one spot with a good fix of satellites in a good environment and conditions. I don't think I really have any multipath around that receiver right now. So it's really getting good results. Okay, so that's RTX into TerraSync. Let's close out of that. Now I'll show you what it would look like if I was going to do more of a cloud-based setup where I can run. So Trimble TerraFlex is Trimble's cloud-based software. So there's TerraFlex Cloud and there's TerraFlex Mobile. The advantage to TerraFlex is it literally will run on any device. So your tablet, your phone, your Windows Mobile, your Trimble device, your smartphone, your iPad, etc. Okay, so I'll go ahead and log in to my TerraFlex account. And let's take a look at how in a cloud-based app, which is things are done a lot differently, and most of your apps don't give you much control at all over the GNSS components. They're just taking the data in and very little concern over that element. But in this case, we're actually we're using a cloud-based software like this, but we're trying to do very high accuracy mapping. So I'm paired to the R2. I've got the antenna height. And I've set up, I'm using range-point RTX as my correction source. Okay, so I've got that set up. So then when I'm in TerraFlex and, say, viewing a project and a map, I can highlight and determine where I'm at accuracy-wise in an app. So again, like I mentioned, the apps really aren't geared today to give you good control over, most apps I would say, over the accuracy you're trying to acquire. So in Trimble TerraFlex, it's a cloud-based technology that's still giving you the benefit of high accuracy capability. So you can see here with RTX, I've got 10-inch accuracy, 14 satellites. It's giving me good control. I could look at that. If I'm in an open environment, I can feel pretty confident about the data that I'm collecting, that I'm going to be in that 10-inch realm. And so it gives me some useful information there to use. And one thing that's nice, say for data like this, if you're not really, this Esri collector, the R2 with the real high accuracy element is really geared today towards, if you're going to use an app, towards Trimble TerraFlex. You could use it with collector, but you can't get that high accuracy element. You're more probably in the sub-meter range if you're using collector. So TerraFlex is a tool to get go beyond that and even collect centimeter level data. And so if I collect some information in here, if I want to map something, I've got, it's telling me my accuracy right here. So if I go through and map whatever I want to do, go through and fill out the form, give it a condition. There we go. Fill out complete the form. Okay, so that information, the really great thing about having that real-time corrected like that is that went already to the cloud, went to the Trimble website, and it's already, been corrected. I can very easily take it into GIS right from there. So if I log into the TerraFlex cloud site, that data has already been transferred. There's no post-processing necessary. And then go to that project. It should pull up here. So there is my Tuesday, October 27th. Here is that tree I just collected. information about the tree, etc. And so if I'm in, in this case, I can take this data into ArcGIS, however I want to work with it. Doesn't need any additional correction. So a very nice workflow in that case. Okay. Let me go back here. So we've gone pretty fast through the Trimble R2, the Geo7X, talk about the Net R9 and the R1. Those are some different Trimble products that have the high accuracy capability. Talked about Trimble TerraFlex as an app-based solution for high accuracy for mobile devices, any device that you want essentially, or traditional TerraSync is another option to pair with something like the R2. And then you have the capability to use this Trimble RTX correction service. You have different levels of that correction service, and that can give you real-time accuracy. Here's some contact information, myself, Jackson Bigley, and some of my other folks I work with, other parts of the country that you can contact. Feel free to send me an email. If you have any questions, please go ahead and log in any questions that you might have. We can take a look at those. If you want to just send me an email if you have any questions after the webinar, please do that as well. I can get back to you directly on that. Let's take a look, see if we have any questions coming in. Again, sorry for the audio difficulty there, but we're back on track here. I don't see any questions. If there's anything in the chat line, don't see anything there. And we're about 10:30, so we're essentially at the time that we had allotted. Oh, there's a question. Hold on one second. Here's a question that came in. Let me take a look at this. Okay, so if you're looking at how things fit in a little bit pricing-wise, what does something like the R2 cost? Well, if you're trying to do centimeter level mapping with the R2, you're over 10,000. You're around just under 12,000 is the product that includes the multi-constellation tracking, so all the different constellations, so you get a lot of satellites. If you drop into the sub-foot range, they call it sub-foot, but it's really more like 10 centimeter. Then you're in the, I think it's $5,700, $6,000 range. In the sub-meter, you're more in the $5,000 range. And again, you need to pair that to a device. Like I was talking about the Nomad, or you could pair it to a tablet, etc. And then you need some type of field software, an app like TerraFlex, or some software to log the data. So here's a question here. So a common question, one other question just has come in. How do I make sure I gather vertical data in ArcPad? So, we've been talking about these products. A lot of times we're talking about the horizontal accuracy. The vertical accuracy can be a little more tricky to acquire. You need, for example, in TerraSync will allow you to load a geoid model. You can actually get accurate mean sea level elevation. In something like the question is referencing ArcPad. So ArcPad by itself doesn't have the capability to use a geoid model, and all the heights recorded in ArcPad are in height above ellipsoid. So you can use the Trimble position software along with ArcPad to get to the mean sea level elevation. It can be tricky. If you have questions about how to get good vertical data, let me know. But some software supports it, some really doesn't. ArcPad we always kind of consider as not really a very good tool to record vertical data because it doesn't use a geoid model. So you can always send me some questions offline as well if you have questions about not only horizontal but the ability to collect good vertical data. All right, do we have any other questions coming in? Let's see. Doesn't look like it. Well, thank you for attending. It's been about a 30-minute webinar. Hopefully it was helpful for you. Give some good information. Again, feel free to contact me if you have any questions. And thanks for attending, and everybody have a great day. That's the end of the webinar. Thanks. Bye.